Hey yo, what's up guys? Welcome to the video series on functions and graphs. So a lot of people would consider this as the first main topic since you've just been doing mainly revision up until now. But yeah, let's start off with some of the main definitions. Alright, a relation, I guess the easiest way to think of it is pretty much it's a coordinate. So an x and a y. But it's usually defined by a rule, so that's your equation. So domain and range, they're two important concepts in this topic. So just think of domain as all the possible x values. So usually in a set of coordinates, it's usually the first element. So we'll just say all the x values. And when we think of the range, think of all the possible y values. But yeah, we'll get more to that later on. Alright, so a function, it's a special type of relation where for every x value, there's only one y value. So we can actually test this graphically. So just say this circle here. If we do the vertical line test, we can see it cuts twice, here and here. So that means for that x value, there's two y values. So that means this isn't a function. Even if we cut it here, right on the edge where it's a tangent, it cuts once. It still doesn't count because of the first line I drew. So if it cuts twice anywhere, that means it's a relation. So we can see this second graph here. Doesn't matter where you just do your vertical line test, it only cuts once. So that means this is a function. So yeah, maybe we should write next to the circle. And the next one, the hyperbola, doesn't matter where you do your vertical line, it only cuts once. That's why this is a function as well. Alright, so functions can be thought of as input-output machines. So fx, so a lot of people get confused. Just think of it as y. In your normal equation, you get y equals x plus 3. Just think of it as y. It's no different. But if we had an equation with the sub x equals 1, you would write that as f, and then in brackets you put the 1. So just say, we're used to saying, just say y equals x plus 1. And then if we have to sub in x equals 1, you just do it normally. So you say equals 1 plus 3. It's pretty much just the same. It's just that now we have a different form of notation where it actually tells you what we're subbing in that inside the brackets. So if it's x equals negative 1000, we just write f and in brackets negative 1000. And for all the x's, we just sub it in. X equals negative 1000. So let's do this one together. So we'll be careful of the sign. So if fx equals 8 minus x, when x equals negative 9 and 9. So you'd write that as f, and then in brackets, we'll do the first one, negative 9, equals, and then yeah, it's just substitution. So 8, and then minus, so just be careful with your signs. That's why I like these brackets. So minus negative 9, and as you know, two negatives become positive, so 8 plus 9 will give us 17. Then the next one, so f with a 9, so 8 minus our x, which is just 9, so we'll get negative 1. So yeah, it's nothing too crazy so far. Alright, so the next one, same thing, so we just sub in 2. So f2 would equal to, so 2 squared minus 2, and they give you 4 minus 2, which is just 2. Alright, so now if you think about the next one, fw, it doesn't matter what letters in there, that just means what we're going to sub in. So notice how in this one it was a 2, so for all the x's we subbed in 2. If it's a w, that means we just sub in w. So it's going to be w squared minus w. So yeah, same for the next one. If it's x plus h, for all the x's, we sub in x plus h. So it'll look like this. So we put an x plus h here, all squared. and then the minus x, so just minus and x plus h as well. See, I just like to keep it in brackets just so you know that you have to times everything by a negative. So we'll just expand and simplify this now. So x squared plus 2xh plus h squared minus x minus h. And nothing simplifies here, so we'll just leave that as our answer. Alright, so before we move on, just another quick definition. So y, or fx, is the dependent variable because it relies on the chosen x value. So because we choose x values, it will change the fx or the y value. So yeah, I think most of you might have seen that from your science subjects as well. Alright, so we can do some quick exercises. So these are from the Maths in Focus textbook. So yeah, all we're going to do is just state whether it's a function or relation. So remember our definition, for every x value, there's only one y value. So yeah, just do your vertical line test. This cuts once, so that's a function. So I'm going to give you time to just do the rest of this page, and then I'll give you the guys the answers. Alright, so next we look at piecemeal or piecewise functions. This is pretty much just different graphs given different domains. So remember, domains are the possible x values. So if we look at this graph here that I've given you, between the values of -2 and then 1, the formula for the graph is x squared. So that means it's just it's parabola. So you can see that between -2 and 1, there's a parabola shape. So for x is less than -2, that means it's 5. So if you think about it, it's just y equals 5, which is just your straight line here. Y equals 5 there. And then for x is greater than or equal to 1, the equation is y equals x. So remember, fx, same as y. So y equals x squared, y equals 5, or y equals x. So remember, x is just your basic straight line. So after 1, there's your straight line there. So it just depends on where your x value is, which domain you want. So for now, we're not going to focus too much on graphing these, because half of this topic is about graphing. So we'll learn about the graphs later, and then we'll come back and graph these. But for now, we're just going to focus on the substituting. So if we wanted to find the x value, I mean the y value, or the fx, when x equals -2, that means we have to go and pick the correct domain. So -2 is in this first domain because it's less than or equal to -2. So that means you gotta follow the rule x squared. So fx equals, and then -2 squared, and you get 4. So x equals -4. So remember, that means x is around here. So it follows this rule, x is less than -2. So that means the y value, fx, is going to be 5. So you have to pick the correct rule based on the domain for these ones. Alright, so I'll do this first set with you, then you guys can do the second set. So we want to find f a half. So when x equals a half, which domain is it going to be in? So it's going to be between 0 and 1. So that means f a half would be, follow the rule, in this case it's just 3, so we don't need to substitute anything. So when x equals 3 now, that's greater than 1, so we've got to follow the rule x plus 2. So remember, same as before, we just sub in the number where the x is, so 3 plus 2, and we get 5. Alright, so now the next one, the last one, we have to do it twice pretty much. So first for the region -2, so that's less than 0, so we're going to follow the rule x plus 3, so it'll be -2 plus 3, and now plus when x equals 5, so that's this rule here, the last one, so it's plus 5 plus 2. And if you guys do that on your calculator now, or you just do it in your head, you'll get 8. So you guys can try the rest of this page, and remember, just be careful of the signs. Alright, so to finish off this first video, we're going to look at even and odd functions. So an even function follows the rule fx equals f of -x. So this is really important. And graphically it's symmetrical at the y-axis, so the y-axis will split it in half. Odd functions, however, follow a different rule. So it follows -fx equals f -x. So graphically, it's symmetric about the origin. So yeah, if you flipped your page upside down, the graph will look exactly the same. So yeah, most likely when you get questions, you have to prove if it's either an even, an odd function, or neither. So since if you look at the rules, they both have f of -x in common. So yeah, so when you're proving these, always find f of -x first and compare it with the original. If it's the same as the original, that means it's even. If it's not the same, then you find -fx and then you compare it. If it's the same, it's odd. So you compare it with the first one, so f -x, it's just, yeah, so then it'll be odd. But if it's not, then it means it's neither. So if you look at the example here, we're given fx equals x to the power 16 plus x to the power 6 minus x squared minus 1. First we found f to -x, so we subbed it all in, and then it turned out to be the same as our original. So that means it follows the rule, it's even. So yeah, a key thing I want you to point out, you guys probably already know, but if you square a negative number, or if you do any negative number to the power of an even number, it'll become positive. So you already know that. Just say -3 squared is positive 9. So yeah, I want you guys to do a quick calculator test. So take any negative number now. So let's just say, I'll just say -2. And now let's put it to the power of an odd number. So you guys can try 3 and 5. Well, you can pick any number you want. But what you'll see is you'll get a negative answer. So that's a key thing to keep in mind, that any negative number to the power of an odd number, it will still stay negative. So yeah, just keep that in mind. Alright, so let's test whether these two are either even, odd, or neither. So remember, the first step, given fx, you find f negative x. So let's just sub in our negative x. So we know that it's a negative number to the power of an odd number. So that means it's gonna remain negative. So it'll be minus 3x to the power 7, and that would be negative in here as well. But two negatives here make a positive. So plus x cubed. So now we look at it. We can see that f of negative x, it's different from fx. So that means it's not even. So now we gotta test if it's odd. So we find f negative fx. So pretty much just take the original and switch all the signs. So it'll be negative 3x7 plus x cubed. And you can see now that they're the same. So that means that f negative x equals fx. Therefore it's odd. So it's important that you write a concluding statement for these. So you guys can try the next one. Alright, so you guys should have gone that it's neither. So there's the working out if you didn't get it. But yeah, let's just quickly, before we finish this off. So these graphs are pretty much what we proved, the questions we just proved. So this one, the first one, it's even because it's symmetrical about the y-axis. This one that we proved above on this page is odd. So if you flip your page upside down, it'll look exactly the same. And the last one we proved, which is neither. So if you flip it upside down, it may look similar, but all the values are different, so it's neither. So yeah, that's the first video done.